Thank you, Giovanni. Hello, good evening. I should say good morning, good afternoon, good evening, because it looks like the group is in multi-time zones. I have a PowerPoint presentation, and I thought I'd just go through that quickly. And towards the end, I'm going to pick a fight with a couple people and then do a demo and hopefully leave time for some discussion. This meeting is normally 3 hours, right? That's what I was told to prepare. Sorry. So if it's not a breach of protocol, I'll share screen. So everybody should see now a synthetic background. Does that work? Can people see the slide? Okay. So this is a talk that I actually prepared for a couple of different venues, one of which was Craig Lauda's podcast. So it's good to see Craig here. And I'd like to talk about two packages and how they're used together. So one is more sound synthesis and sound processing, and one is more score management and music composition assistance. The first one is called Sizzle, which is the Create Signal library. So it's a C++ class library. And the second one is Siren, which you may know, it's been around for way too long, and is a Smalltalk class library and a set of high-level tools for music composition. So I'll introduce each of them quickly and then give a demo of using them together. Sizzle, I spent 15 years teaching at the University of California, Santa Barbara, UCSB, and in the late 90s started teaching a 2-year-long course on digital audio signal processing. And they have quarters, so it became 6 different 10-week courses on all different aspects of digital audio programming. And as part of that, actually, I think it was right around 1998, I said, just as an example, why don't I write the simplest class library I could in C++ for the students to use? And it just had to be something where you could make a signal processing graph and then perform it live through a sound interface and control it. So sort of the simplest framework. I gave myself the tasks of less than 1,000 lines of C++ for a framework that you could build synthesizers. And now, over 20 years later, it's pretty big. It's been used in a number of products. In the beginning, it used a number of different backends for things like MIDI and audio input, output, and graphics. So there were versions that used Qt graphics and versions that used port audio for audio. More recently, it's all been ported over to use Juice primarily, which is a lovely British invention. In case you don't know it, it's a comprehensive cross-platform C++ library for multimedia. So the idea is to build synthesizer servers, or that's my idea. People have also built other apps and things, but what I'll be talking about today is sort of standalone synthesis servers, essentially the identical thing of a hardware synthesizer, but a programmable standalone synthesizer in C++. One of the other nice things about Sizzle is it's completely cross-platform, so it's been used on Mac, Linux, Windows, and for apps on iOS and Android. I guess the invitation included links to the GitHub page. There are several different versions on GitHub, and there are a number of different demo videos because, as I mentioned, it started as a teaching tool. And so there's several videos walking through how do you write code in Sizzle. Just since people love class hierarchies, this is an example showing the top part is oscillator class hierarchy. And you'll notice right off the bat, it uses multiple inheritance, which is something that I'm sorry we never followed through using in Smalltalk. But oscillator has a number of superclasses, and then underneath you see all the different subclasses for specific kinds of oscillators. And then the lower part of this chart is for the class filter, as in audio filter, where you see, again, multiple superclasses and then the concrete subclasses. People like to see code examples. Sizzle is not the most advanced in terms of language model. It's kind of a procedural thing. You connect, you create objects, and then you plug them together, and then you send messages to the root of a signal processing graph. So here's a very simple example to play white noise that is sent through a bandpass filter, and to have both the center frequency and the bandwidth of the bandpass filter controlled by time varying functions. So you see here class names over on the left, like white noise and rand envelope and butter, which is a kind of filter. So we create these objects, and you'll notice when we create the butter filter, we pass into the constructor the input, the bandpass, the noise, and then the two envelopes. Then there are calls towards the bottom to trigger the envelopes. And then we just take the Butterworth filter, which is the root or the output, so to speak, of the signal processing graph, and we pass it to some global I/O object, and that automatically will start playing. So this is admittedly trivial, but it's pretty easy to learn how to plug these together. And in the courses I was teaching primarily, it was teaching students to extend these, to write C++ code to build new synthesis, spatialization, processing, control kind of objects. As I mentioned, it was also used with a number of different graphic user interface packages. So here, two apps. These are both, I guess, using Juice. The one on the left is a birdsong analysis tool. We built an expert system for analyzing bird songs. So we call it Shazam for Birds. And this was just a way of debugging it. So you could see, I guess, in the top right, the green plot is literally the oscilloscope of a bird call. Underneath it is the spectrogram, and overlaid on the spectrogram is a bunch of different derived metadata functions. And if you look at the spectrogram kind of in the upper right, you see the legend. So it's showing us pitch and pitch estimates, so two different pitch estimates, and spectral harmonicity in yellow, and then at the bottom of each plot in red, the amplitude. So this is just a way of training and then debugging these rule-based expert systems for birdsong. The figure on the right is a granulator, so a real-time performance tool, just again using Juice and for real-time performance. Here are some of the commercial apps that have been built. Everything ranging from recording studio hardware to the iPhone you see is the Birdsong app. And in the middle is actually another British production. It was a game I worked on several years ago called Papa Sangre, which was, I thought, interesting because it was a computer game that had almost nothing going on visually. What you see on the screen, the direction and the 2 feet, was the entire graphical user interface. The whole game was done with 3D spatialized audio in your earbuds, where you would be moving around this space, and with the controls, all you could do was turn left or right and press on the feet to walk forward. And it was a kind of a Dungeons and Dragons game, but it was extremely non-visual. So they needed extremely accurate head-related transfer functions to do the spatialized audio. So if you have this notion of a signal processing graph, if you make it reflective, in other words, give it accessor objects for all of its parameters, you can make a standalone instrument. And then you can construct libraries of instruments and make these standalone synthesis servers. And they can respond to MIDI, which stands for Musical Instruments Digital Interface. It's a hardware standard that also can run over software ports, sockets within a program. Or it can use Open Sound Control, which is a standard based on Ethernet or user interfaces. So this is what I've been using for a number of pieces to make complex, multiple different instrument libraries for real-time interaction. So as an example here, you can have a sample file player, essentially just a sampler. And you see here it has a number of different inputs, like set the file, set the amplitude, set the rate. And the strings, like FI and AM, those are the tokens of the Open Sound Control messages. So it's just compact. And then it has a number of different formats to play. So if you set everything up, you could just say, play this amplitude at this spatial position. Or you could add, for each note, you could have a varying number of arguments and argument types to specify, every possible parameter at note runtime if you want to. So on the right here, you see The open sound control address space uses slashes, so it almost looks like Unix file names, but it's how do you address in a complex server, address a particular function. Are people familiar with open sound control? I guess I can't see you, so I don't know, and you can't yell. So here's, I guess I'll go through this quickly, but here's the kind of code you would use to build a large multi-timbral software synthesizer. You create an instrument vector, you create a mixer for the output, and then you see these loops just go through and create a bunch of, well, the first loop creates 16 plucked string instruments, and you add them to the library and you add them as inputs to the mixer. So by the end of this page, we'll have 48 different instruments in our instrument library. We'll have 16 strings and 16 singers and 16 FM bells. So as I mentioned, we'll see some examples of this actually using this exact library later. So the Siren system has been around since '84, or was parts of it go back to it. Actually, the oldest code, I think I found code there from '86. So I don't think I have any of the original '84 code, but it was '86 was the first time I had a machine that was fast enough where the garbage collection was fast enough that it made sense to try writing a real-time scheduler. And that real-time scheduler is still in use. I guess here I could take a diversion and just say, I was lucky enough in 1984 to meet Georg Haig. I was living in Germany and working for a computer company, and I was actually doing graphics and AI. I've mainly maintaining Lisp and Prolog compilers, but also doing the Windows system. And Georg was at the university in Dortmund and called us and said, we've got a bunch of your computers and we just got the new graphics. Have you guys ever heard of BitBlit? Have you thought of supporting that? And I said, that sounds cool. That sounds like Smalltalk. Why do you want BitBlit? He said, oh, we're porting Smalltalk. I have a bunch of students. So that was the first time, I guess I had seen Smalltalk in 1977, but that was the first time I ever had actually access to use it because I helped Georg port. I mean, we had a BitBlit library in our graphics, but it wasn't being used for anything other than text. So the fact that he wanted external library access to BitBlit was very exciting. And since there's some Germans on the call, I should say that I definitely owe Georg Haig. So the Siren package consists of a number of different elements. There's an underlying music representation language, which is just an object model of musical objects. Then there's a set of schedulers and I/O drivers, basically ways of taking these objects that are abstract and a network of representation objects and mapping their abstract properties onto the concrete parameters of some output format. There are a number of user interface components for building musical applications and several built-in applications themselves. So here's again, this goes back, I guess, to the late 80s, early 90s, this picture, early 90s, I'm thinking. So in the middle, you've got SMOKE, which stands for Small Music Object Kernel, and is these two ideas of music magnitude models and objects for functions and sound and spectra and other musical objects. And then you combine them with ways of making event lists, which you would think of as being melodies or chords or musical scores. And all around the SMOKE circle are things like higher level musical objects like event generators and event modifiers, and then I/O objects like user interfaces and tools and schedulers and input-output means. Again, Siren is on GitHub, and Giovanni sent you the link. There's also a 2007 video. I don't have any of the older videos, but I made a new video also, but they go back to 2007. They're on Vimeo and they're linked to from the GitHub page. So the SMOKE music representation, as I mentioned, consists of Smalltalk objects that represent music magnitudes, things like pitch and loudness and duration. And here's something interesting that I didn't put in the slide, but I just saw a paper. Somebody mailed me a paper from last year or 2 years ago, maybe, about sort of simulating multiple inheritance in Smalltalk to have magnitudes that have two dimensions to them or two aspects, one of which is what do they represent, and one of which is how do they work? And I thought this was very interesting. And the way I do that is I use the species message, which I don't know, it's pretty obscure. Nobody really seems to pay attention to it. But in Smalltalk, we know that every object, you can ask it, what is your class? Well, you can also ask it, what is your species? And in class object, that is the species method is written to just return your class. But you can override it. And so you can have methods that depend on the species rather than the class. And what this allows me to do in the magnitudes is, let's just take pitch, for example. We all know that there are note names for the notes on a piano, like C and D and E and F. We also know you can describe pitch as a frequency. In other words, give it a value in a floating point value in hertz. You can also describe it symbolically. You can also describe it graphically. And what's interesting is in a sophisticated system, you want to be able to do mixed mode arithmetic on different representations. So how about if I were to say middle C plus 8 hertz? Or for duration, something like a quarter note plus 15 milliseconds. So I have one set of the hierarchy classes that are sort of the abstract representations, or those would be the representand, meaning what is represented, and then another whole hierarchy of how are things represented. Are they symbolic? Are they numerical? Are they using a lookup table, a gamut of some sort? So it was very interesting that I published a few things about this years ago, and then somebody just did it, and they had examples coming from finance where they're talking about currency and value being complex models, and also chemistry where you have a lot of these chemical properties that have complex models to them. So at any rate, given music magnitudes, you basically can think of an event as just being a dictionary of magnitudes that has some time extent. And an event could be everything from a single tiny grain all the way up to the entire composition. So using well-known design patterns like the composite pattern, event lists can contain event lists, can contain event lists. And we'll look at some examples. The last thing I want to say here is that we mentioned before these middle level structures. You see the second line from the bottom. So for composition, it's very interesting not just to have to work at the level of notes, but to say, here's a set of chords I want to work with, or here's 2 or 3 different pitch sets or tunings or gamuts. So there are middle level structures representing things like stochastic clusters or something as simple as a drum roll. Why not have an object to say, if you're going to repeat the same note many times, let's just call it a roll. Well, I guess the bottom thing bears saying, there is no actual time model in Smoke. There's a duration model. So everything is relative to something else. So every event list starts whenever it starts, and within an event list, the events can be separated by durations. Here's some simple examples. As I mentioned, a note can just be a concatenation of magnitudes. So this first line, 440 hertz, 270 milliseconds, 44 decibels, I override the comma operator so that if you send comma to a magnitude, it creates an event. And if you send comma to an event, it just adds new properties to the event. And events are smart enough that they can look at, if you give it a hertz and a milliseconds and a decibel as properties, it'll do the right things and assign them to the expected properties of the event. You can also have a more complicated expression like mixing different representations. So 60 key might be the name of a key on the keyboard, 1/4 beat, fortissimo as an amplitude. And then you'll notice these associations where I just say voice associated with flute. Those, again, it's just going to add new named properties to the musical event. These middle level objects, well, to create a chord, you'll notice here, I have a special kind of an association. The equal greater than is what we call an event association, which is it's a type of association with some extra behaviors. So if I say 0 associated with this note and 0 associated with this note and 0 associated with this note, and the notes being D, F sharp, and A, that's going to give me a D major musical chord. And by the fact that the events all start at the same time, that's how I know it's a chord. Here's another example of an event list constructor. So the class event list has dozens of constructors, like give me a scale from this pitch to that pitch in this many seconds. In this case, we're just making a C major scale. The screen, if you are familiar with it, it's called Hauer-Steffens notation. It's like regular piano roll notation. The advantage is it was invented by Joseph Matthias Hauer in the 20s. I guess I should say in the 1920s, not in the 2020s. He was a 12-tone theorist. And the nice thing about Hauer-Steffens notation is that pitch is linear in space. So you can see things like inversions of pitch sets. But that's neither here nor there. These middle-level objects, called event generators and event modifiers, are just simple Smalltalk classes that generally have one or more constructors. Some of them have many different ways of constructing them. And then they have methods to return their event lists or to be applied to an event list. So you see these examples like a chord or a cluster or a cloud or a selection cloud. So randomly selecting from different arrays or sets of things, or dynamic selection cloud where you give it a beginning and ending things to work with. And then more traditional musical objects like roll or ostinato or trill. So these are just, again, higher level or somewhat middle level objects that can all return event lists. So they can be, you can operate on them as the event generator object. And then if you want to play it, you just say, give me your event lists. Here are a couple of examples. The first one is a dynamic cloud where I've given it beginning and ending ranges to select from. So you see it says pitch, and it starts with the range 30 to 49 and ends with the range 60 to 60. And if you look at the lower left-hand screen, you see that at the beginning in the left, there's an octave variation within the pitches, and towards the end, it focuses in on this single note on C4. And the amplitude is getting much louder. And in this particular notation, the little red line going up from the note head signifies amplitude. So you see at the left-hand side, the earlier notes, you can hardly see the amplitude. And by the time we get to the end, the amplitude is, well, on my screen, it's like a 1/4 inch tall. So that makes sense? A simple object that can create a musical structure based on varying stochastic selections. The lower right-hand screen is similar, although you'll notice at the beginning in the left, it's picking notes primarily from the lower chord and gradually transitioning so that by the end, it's always picking notes from the upper chord. So these are just simple event generators that are based on some determinism and some stochasm. So how do I use these things together? Well, the Siren system runs compositional algorithms and user interface interaction, and it talks to backends either through open sound control to talk to SISL servers or to traditional MIDI synthesizers through MIDI. And of course, because open sound control and MIDI are both widely supported, you could use any other backend, any synthesis component, like an actual hardware MIDI synthesizer or other pieces of software that respond to open sound control. But I normally interact with things in Smalltalk, and then the Smalltalk has a real-time scheduler sending things out to either MIDI or open sound control or both. So the summary here is just, these are open source cross-platform toolkits specialized for music composition and performance. And they both have links on my homepage, which is FastLab, and they're both on GitHub. Do we want to pause here and ask if there are any questions? Or I see some of you are still logged onto the meeting, it looks like.
I think it's about, are you going to give us some demos of some stuff? Are you?
Yeah, well, before I went in the demos, I want to ask if there are questions on the PowerPoint part.
I have a question.
Is it Craig or his cat asking?
Oh. Don't mean to cut someone off.
No, I think go ahead, Craig.
Okay. Well, Stephen, what did you think of using traits for modeling the what-how duality?
Well, when I started doing that, they didn't really exist. So, that was the smoke stuff is some of the oldest code was literally done in Smalltalk 80 version 2. There are obviously many other ways to simulate this sort of multiple inheritance, and traits would be a way, although the species, it seemed, is even simpler because it literally says every object can have 2 primary ways of inheritance, your class inheritance tree and your species inheritance tree. So the mixed mode arithmetic is really simple, and each of the abstract classes just has a table saying, here is the generality of things that are my species. So it says if you're trying to, if I say, C# plus 40 hertz, I leave it up to the pitch representation class to say, coerce the symbolic value into a hertz value, since the hertz value is more general. But it could be done with traits, it could be done with multiple inheritance. So it's not. Other question?
I would like to ask you, Stefan, a question about CSL. In the snippet of code you showed us how to build a simple object graph. And my question is, how do you get from that code to the real-time code? It looks like C++, so I guess that maybe you just compile, and that means that each time you modify that graph, you need to call a C compiler and recompile everything. Is that the case, or is there any way of dynamic connecting objects for that graph?
No, simple answer is no. There are people in the JUICE community, there is a kind of rapid turnaround compile that doesn't do a full compile and does dynamic linking. I haven't really used that. I normally develop the code in either Xcode or something like Eclipse, regular C++ coding environment, and you do a full compile. But of course, it's not it's not that difficult because it's not a huge amount of code. It's not linking in tons of GUI libraries and things. A Sizzle server is normally pretty tight, so it takes it, a few seconds to a couple seconds to compile and link. But it's definitely that longer cycle than have something running and be altering it like you could do in Smalltalk.
That means perhaps that in Siren you have maybe something like 2 levels of interaction, making a difference between the things that require a recompile of the CSL code and the manipulations you can do in real time and just apply them and keep playing. Or how do you handle that?
If you wanted to change a server in real time, normally if you're playing, you've assembled your instrument library. So you're not generally changing it in real time. So that's definitely I wish it were different in C++, but this incremental linkers are still hard, and they end up being very platform.
There is a difference between building and playing.
Yeah.
Okay.
Which is a difference also, since you saw the presentation of Kima. I've been talking with Carla Scaletti and Kurt Hebel since the mid 80s again. That at the time it was just, I was saying, well, look, if Smalltalk were fast enough, I would, but I had to have. Now, the main reason I started working with Sizzle was just, I was in a teaching environment, and I couldn't expect students to all learn Smalltalk. I did require them for this digital audio course to all learn C++, just because, especially back in the 90s, I could say, look, commercial apps are written in C++, period. They're not written in Python or Visual Basic, or if you're talking about digital audio effects, recording studio products. Now you could maybe argue that there's more. Well, now there's chaos. So there's stuff in Python, there's stuff in Lua, there's stuff in Faust. But at the time, we decided in designing this course sequence that everything is in C++. And
And have close applications, I mean, for people who are not C++ programmers, been built that let you build your instrument library and generate call the compiler and do the C code and build that stuff together, or that's only for coders?
Well, you can also just use any MIDI synthesizer. So you don't have to use, you can use Siren with MIDI hardware or Siren with a MIDI software synthesizer. And in the demo, I'll be using both at once. So I'll have some MIDI. There's a product from Native Instruments in Berlin called Contact, which is an extremely powerful sampler. And I said, I don't need to reinvent the wheel. If I want to just sample playback, I'll use Contact and talk to it over MIDI. And if I want to have my own sounds, I'll use Sizzle.
I guess in that case, you would want to maybe expand the Siren with a model of the parameters of those hardware synthesizers, so you can also tweak them at the same level that you tweak your musical events, right?
I'll remember during the
out
code
of the
part.
playing.
Yeah, there's absolutely a way you build for each instrument in Open Sound Control or MIDI. You can have a separate map of how do I map. Again, we're talking about this mapping parameters of something abstract onto properties of something concrete. And that's, you could make specific ones for a specific MIDI synth if you want to control over things that are not standardized.
Cool, thank you.
Okay, then I just wanted to finish with a couple of slides.
I think there was one other question. I think Carl had a question. He raised his hand. I don't know if Carl wanted to ask something.
Yeah, thank you. Thanks for this. It's great. I was just curious. Obviously, you found that C++ was necessary for a couple of reasons, including speed. But what would you say, or since you wrote music software in both Smalltalk and C++, what would you say the strengths of Smalltalk are in this scenario, and perhaps maybe some things that might cause some issues with acceptance in this particular sphere?
That's a great question. Thanks, Carl. We just sold our house here in Santa Barbara, and in real estate, they have this term that there are three things that matter in real estate: location, location, and location. And since the 80s, I guess since I worked in Lisp, I've said the three things that matter in coding is malleability, malleability, and malleability. So I would say that the idea that in Smalltalk, you can change something while it's running, you can find things. When I demo Smalltalk, I always demo changing something while it's on and then crashing the system and recovering, and these things that we take for granted, and that if you go to other systems, you just don't find them. Adele Goldberg and I we once wrote a paper called Object-Oriented is Not Enough. And there we said that, this was in the late 80s when C++ was starting to become popular. So our way of dissing C++ was to say, adding classes to a shitty language doesn't make a good language. The additional things that you need is a class library and a set of tools that understand the language on the library and a methodology that is used in the library. So things like the design patterns. And so we said, great, use C++, that's fine. You won't have the Smalltalk class library or the Smalltalk browser or the set of object-oriented design patterns that are evidenced in the Smalltalk class library. And for me, it's still, I'm more effective in Smalltalk, but it became, I would have one student every year or two who really wanted to get in, or some students who knew Smalltalk and came to Santa Barbara because of it being active there, but just didn't become mainstream. And well, that's a good segue to the next slide, actually, Carl, if you don't mind.
Sure.
So starting, did I skip one? Yes. At the beginning of 2020, actually, before the stuff hit the fan, I was starting a new piece, and I said, well, I should just look at all of the new Smalltalks. And so my normal test when I open up a new Smalltalk dialect or a new implementation is how much time and how much code does it take to A, move the scroll bars on all windows to the left where they belong, because we read from the left. And B, recreate the 6-pane browser or the category browser, or what do they call it in Squeak? It's called the package browser, right? In other words, to parse class category names into a 2-level hierarchy so that the leftmost column says magnitudes, collections, streams, files, graphics. You basically, you should be able to navigate the whole system without scrolling any of the lists in the browser. So there should be a dozen top-level packages, and then in each of them, a dozen or fewer sub-packages. And I just remind people, I put it on this slide to remind me to say, one of Adele's famous rules of reuse was, if you can't find it, you can't reuse it. And the second rule was, if you don't trust it, you won't reuse it. And
that would limit, sorry to interrupt you, but that would limit the system to less than 2,000 classes, right? 12 by 12 by 12 is less than 2,000, I guess. Yeah.
But it has to be a balanced tree also, which is harder, Juan, right? To keep the tree balanced so that it works.
Yes, it would be way less than that, of course.
So in my porting effort, I would generally then try to port the display list framework, and we didn't really talk about that, but for portability, all of the Siren user interface stuff uses my own display list framework and display list view that can talk to the VisualWorks wrapper style user interface library, or it can run on top of Morphic. And then I guess the last thing is important that I have to figure out for a new dialect, how do I talk to the back end, to sockets or foreign function interface or native code calls or DLLCC. So those are the things that I face in a new port. Well, so earlier this year, I went through a number of the different current dialects. And this is just my very personal and unfair characterization. And ++ means advantages and - means disadvantages. So VisualWorks is stable and has the wrapper GUI and good tools, but it's expensive and it's bloated, and they removed class categories as a primary way of browsing. And for me also, nobody is maintaining SWIG anymore, which I used very heavily. If you don't know SWIG, it stands for Software Interface Generator. And it was a way of making glue code between different languages. So you could say, I have a C++ library and I want to have Python objects to talk to it, or talking between Lisp and Faust. So it's really a nice way of making software interfaces. And there was a fellow who maintained it for Smalltalk for several years and it stopped. So unfortunately, I used it heavily in a number of projects. Squeak, I was involved very early on, and it is now widely used, but it's massively bloated. And I will say, here's my opinion thing, Morphic stinks. Any user interface framework that where the root class has, 7 or 8 instance variables, that just means your garbage collector is going to be punished. You have these windows made up of lots and lots of subpanes, and every morph is a couple hundred bytes. And also they don't differentiate between views and controllers. There's a reason MVC had 3 parts. Okay, I'll get off that. Squeak also just has poor naming, that everybody, of course, you want to have your cute name at the top level, not, for example, the class category names for Siren are music-events and music-. I didn't call it Siren-. It would have been much cuter. But to have top-level things called Balloon and Monticello and what all the stupid names are, I'm sorry, that makes it harder to find things. It's not just my opinion. It makes it a lot harder to find anything. Faro, I really enjoyed the early versions. More recently, the language extensions and the non-standard tools and the complicated tools. I think I spent 2 full days just trying to make the 6-pane browser, and the browser classes are so over-architected. And again, there's hundreds of classes just to make a code browser. So I just ended up giving up and saying, all right, I can't find stuff. It's too complicated. There's too much going on. I mean, it reminded me of the VisualWorks refactoring browser. It's like they didn't make a simple browser. They made the grad student version of the browser. Quis, I really loved it, the fact that it stripped so much of the bloat and ran on the high performance modern virtual machines. But unfortunately, they also stripped the MVC classes, and it uses Morphic. And I actually talked with David Liebs. This was probably April or May. Tried to get him interested in porting wrapper, but it would have meant going all the way down to BitBlit, and we didn't want to have to rewrite it, and we didn't want to get sued by stealing code from VisualWorks. But my perfect dream would be a version of Quis that has model view controller and something like the wrapper framework.
Sorry to interrupt you again, but I can answer to that. The thing that I can say, as the main developer, if you wish, of Quiz Smalltalk, I would be more than happy to work together with you or anybody you can get to work on that kind of projects, and you will have my full support for making them real in Quiz. Just that.
Thank you, Juan. Let's talk about that offline.
Right, wonderful, yeah.
Maybe we should do the demo now, because I don't want to go too much over time. I guess this was just to show you what I'll be showing you, just in case the demo crashes. So we'll be using, well, I guess I'll just go. How do I do this? I escape. Now we're back there. Well, let's just, do you have Smalltalk now? Okay, so this is a VisualWorks environment. The screen colors are mine, but otherwise it's pretty standard VisualWorks. Here's what I call the workspace outline. That's another thing I always try to port, of just a book model. But Siren comes up with a whole pretty intensive document that's available as a web page or online. And of course, the fun thing about having it online is that you can click things and use them and execute them. So we start talking about different ways of having music models, and we can say, well, what okay, so duration 16th note as milliseconds. What? Oh, gives us 62 milliseconds. I don't know why it lost the package names. So I'm not going to go through this whole thing, but if you want to, you can fire up Siren and just go through this as a way of learning it. And it goes through so it starts off with the music magnitudes and the basic underlying models. And then there's a whole separate thing of pitch classes, which is submitted by Francis Pachet's group in Paris. Events, again, just look like concatenations of magnitudes. Event lists are just, again, it's the composite pattern. So an event list is just a subclass of event that holds on to a collection of events. So they can be nested arbitrarily. So simple things like this, or you could write out longhand if I wanted to have just a fugue theme. This is like the most verbose way of describing a melody. And then I mentioned that event list class has all sorts of ways of creating them. So things like from selectors and values, and these are useful to build other packages that have smarter ways of creating event lists. Control functions, I don't think I'll go through too much of the different details, but there are functions of time. Event generators, we mentioned, things like clusters and roles and clouds. Event modifiers, pretty straightforward. I could create something and say, apply a crescendo to it, or apply a time, what musicians will call a rubato curve, time mapping curve. Then there's a whole set of real-time schedulers. Voices are the objects that handle this property to parameter mapping. So all of your composition can be using abstract properties, and then you can say, play it on the piano or play it on the software synthesizer, and there are different kinds of voice objects. The graphics framework is, as I said, just based on very simple display list representation. And yeah, let's stop that and look at some code. So here is, for example, the music model representation classes. So if we look at pitch, for example, the class pitch has a bunch of constructors and, well, it doesn't really have anything on the instance side because it is used as a species. It's another way to think of it. I guess Craig mentioned traits. I think of it as a mixin, which is, I guess, just because I come from Lisp originally, but it's kind of lighter weight than an actual superclass. So I think of mixins. If we look at the implementation classes, for example, a MIDI pitch, it just says its species is pitch. And you'll notice it has these coercion messages on the instance side. And it can tell you which is the most general version of it. So here are things. Hertz pitch also has different coercion functions, but has the same species message. So this allows you to do mixed mode arithmetic. And it's not just, if we go back here, you'll notice it's things like amplitude, chroma, which is a very abstract version of pitch, chronos, abstract version of time, directionality for spatial music, duration, ergon, most abstract version of energy, etc. So there are a lot of these abstractions that can be useful for writing compositional frameworks. I guess since we had the question, here's just an example of if you have a specific synthesizer that has specific controls, here's how you create the parameter map for a given instrument. And you'll notice I'm just creating a dictionary. In this case, it creates something called a typed open sound control message. And it can coerce different properties of the event into the specific parameters of a given synthesis technique. And here you'll notice for different instruments, some of them take a whole lot of different properties, and some of them are very simple. Yeah, we can come back to code if that's interesting. What I wanted to show was two things that I've been working on recently, just literally works in progress. And I guess we'll start with the newest one. There was a language that was popular in the 70s and 80s. It started with a language built at Stanford called Score, which obviously enough was a language for writing musical scores. And then in the early 80s, a fellow in New York, Alec Brinkman, wrote a version called Score 11, which was just ran on the PDP-11. And it's a way of creating, it's a shorthand for music notation, basically. So here, for example, I could just say, create a score, and P3, which is traditionally what's used for the rhythmic values, just give these rhythmic values, like quarter notes and eighth notes. So this would be 3 quarters followed by 2 eighths, followed by 4 quarters, followed by 2 halves. Can you read that? So it would be da 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 da. And the pitches, again, this is just a real convenient shorthand for creating, especially for transcribing traditional music, or if you have something that you think of as being tradition, it's just a good shorthand. And now let's see if this runs. And it's not running because what? Oh, because I'm trying to play it out. Here's why you're not hearing anything. My Open Sound Control server is waiting to be started. So this is a Unix shell, and I'm just in the directory where I have different Open Sound Control servers. And it takes a while to start up just because it loads a whole bunch of data. But let's keep this up and try that again. Could you hear that at all? Just coming through my microphone. It's probably very quiet, right?
Yeah, it came through.
Okay.
Yeah.
So if you care, this is from Tepsichere, or Tepsichere if you're Greek, from Michael Pretorius. So the score is just a very simple way of transcribing things as a shorthand for notating music. I also have examples of Bach chorales where you have the same note lengths, but then when you use colon, these are chords. So this is just a transcription of a particular Bach chorale. So I've been using it for a piece. I wanted to make kind of an homage to John Chowning, who's a very famous computer music composer from Stanford. He's also the guy who sort of discovered the use of frequency modulation for sound synthesis, which is a big thing if you know about FM. It was actually for a time, the biggest patent or the richest patent that Stanford University had. And I'm told that the university Office of Research would go to the engineers and say, isn't it ironic that the richest patent we have is for music synthesis, not from something you guys came up with? So this is kind of an homage to one of his pieces by just, well, let's read it together here. It's from a piece I'm working on called Sleeping Sword. And this is something Craig hasn't heard. It starts with 3 5-second, very quiet, so I'll turn it up, segments. And so what this expression here says is, for example, in 5 seconds, move exponentially from 0.8 to 0.8, from the range 0.8 to the range 0.1 to 0.12. So it's like it's what we call a tendency mask. So these are just, I give the durations, and the pitches are all also these moving stochastic tendency masks, as are the amplitudes. And then I can start sending messages. Well, I guess I finish it by saying all these different parameters of the notes. And then I just say, well, give me that event list and take the first 34 seconds and remove the last. So now this is all creating the abstract score, but then I can say, well, just give me the events and now start playing around with the events and assign instruments to it, etc. Then after 15 seconds of that, I have another block here that's very different. I call it the spinning cloud, but it's described similarly. I call that score 2, and I create the abstract object, and then I create the event list, and then I start processing the event list. Then I can go through and apply blocks to them, like to have specific pentatonic scales or Boland-Pierce scales. And at the end, I just create a voice, in this case for a frequency modulation bell sound, and just play it. So this is a play about, what is it now? 30 seconds or so. And I'll turn it up because it starts very quiet. Or maybe I'll turn my microphone towards this. There we go. So that again was Smalltalk talking to this C++ backend server here. And you'll notice it went, the background, I guess, is if there's nothing playing, it still has a reverberator. So that takes about 3%. And while it was playing, it went up to 4 or 5%. And for some reason, the reverberator is now soaking up cycles. So I will kill that and restart it. And now let's go on to a different example. So I mentioned this talking out MIDI. So all of what we were just seeing was Siren talking over a network protocol, over a socket, obviously just within the computer, but it could have been on a separate server on the internet, talking open sound control to the C++ server. I also have running this, which is Contact, which is a commercial product that's a MIDI sampler. And here you see all the instruments that I have, but what I set up for today is 4 instruments, an organ, a glockenspiel, a glass marimba, and a gangsa, which is a gamelan instrument. And if you see there, right there, you can see it's on MIDI channel 1, MIDI channel 2, MIDI channel 3, and MIDI channel 4. So I can now address these independently from Siren now sending MIDI to this. And I'll just get that out of the way. So what I built for this, just a sketch, but I wanted to be able to have real-time control over layers of things and start building things up in layers. And this is actually what comes before what we just heard. So I'm playing them in, I guess, the reverse order. But here you see a little controller where I've got 14 different players, I call them, but they're just little blocks. I guess let's go look at a player just for giggles. Where is that? Can I even find that? Where? I don't even remember where that was. Pitch, sound, support, apps, LPC. Huh? Where's the player code? Well, we'll get back to that in a question. But these are simple objects that hold on to a block of Siren code, frequently using these stochastic things, but each one has different parameters. And I have 2 plucked string threads. I have 2 voice, so spoken word sample threads. I have 2 instruments that make low frequency drones that do vector synthesis between orchestral instruments. So you can say, play a very low note that starts as a cello and ends up as a contrabassoon. So each one of them has kind of a dynamic timbre. And then those are all being played over open sound control to Sizzle. And then the MIDI are these random walks on each of the 4 different MIDI instruments. So maybe I'll just bring this up so we can see it showing us something. And I'll just start with a random walk.
Shine. Move.
Well, the vector voice instruments are certainly broken. Let's see if they, no, we appear to have crashed the, here, I'll show you what's going on here. As soon as it started playing the vector instruments, something happened. Can it recover or not? Okay. Well, I guess that's a good place to stop with the crash. I guess I should show, well, this is, so just to finish up the demo part, maybe, bloop, there are these 2 little things that nobody asked about. One is just, it's the visual works transcript, but one of my little hacks that I've been doing for years is adding things like opening special browsers or having just a menu of your debug expressions, like what are the things I do most frequently. So just to start your demo, or if you're debugging something, it's just like having a window open with a do it, but this is this menu that you can add items to. And then I have a couple of different sort of configuration and setup tools. One's called a transport and the other's called utility. So this is manages all my real-time input output. Sometimes you have to just stop all MIDI, for example, if your scheduler gets screwed up, or change the sample rate of the audio processing. And then I guess I can show the other one. There we go. You can also manage the database that you have with, that you have within Smalltalk. So this is kind of their partners, the utility and the transport. And here I can look at all of the different IOs that I have, or my dictionary of event lists, if I'm storing a lot of data in the image. And I'm a little over time, so I think I wanted to stop there and ask for questions or debate. And I'm a little over time, so I think I wanted to stop there and ask for questions or debate.
Okay,
I have a question.
go ahead, Craig.
What do you think of using protocol buffers as a replacement for Swig?
Okay, now I'm going to sound stupid. What's a protocol buffer? Have you ever met one?
Oh, okay. Well, something you might want to look up. It's fairly widely used proposal from Google for doing polyglot stuff, getting multiple languages to interoperate with functions and data.
Well, Swig is good, and it's still being maintained and is supported by 50 or 60 languages. And it's, I think, for over a decade, been kind of a very standard way to interface between. It's mainly for, talking from a scripting language to a compiled language. So it's very frequently used to make, it basically can parse your header file. That's, for example, a C++ header file with a class hierarchy in it, and just say, oh, I will map that into a Smalltalk class hierarchy and make the DLL-CC links. So it's painless. If protocol buffers does it that well, I mean, Swig is still, I have students that still use it for Lua, for example. And there are a lot of apps that are Python talking out the back to C++ or any other compile language through a Swig interface.
Cool. This might be interesting as well. It's mostly getting uptake with web languages. Sorry?
Yeah. Well, Swig is still in the VisualWorks repository. It's just, it doesn't work in any modern version, and I'm taking the time to fix it.
Oh, okay, so it could be made to work.
There are an awful lot of people on this call who obviously have too much time on their hands, so.
Well, that sounds dangerous, but could you say something about why Swig is important? I mean, it was top on your list when you talked about VisualWorks. It always sounded like a good idea to me, but nobody ever got around to implementing it in Squeak or other dialects.
It's a cross-platform way of doing foreign function interface. Right? In the old world, it was just external calls or many ways of calling it, but it was both cross-platform and cross-language, and it was automatic that you could just, generally you would take a C++ project or just write a program using Boost or Juice or any big thing, and you make a subset of the header file to say, here's the set of classes and their methods that I want to have reflected into Python or Smalltalk or whatever. And then it just automatically makes all of the glue code. So now your Python or your Smalltalk program just can instantiate objects in this other. I mean, I used it several times with a project called Loris, which is a wonderful C++ signal processing library. And you could just instantiate a C++ processing graph from within Smalltalk and send messages to the individual objects in C++ from a Smalltalk program.
There was Swig for Faro.
Say what again, Stefan?
There was Swig for Faro.
Oh,
But it looks like it's 2014, so that is probably the old FFI.
yeah, it obviously is tightly coupled to the foreign function interface or dynamic link library connect of the host language. So it's that part is going to be different if for different versions of Smalltalk or between Smalltalk and Python and Lua and other scripting languages.
Yes, I guess I can ask Ronnie what happened with that.
As you see, I get around it by using either Open Sound Control or MIDI. So, but it would be nice to be able to create a sizzle graph, a signal processing graph from within Smalltalk. There was a time when we did that you didn't even have to program in C++. You would just load the entire sizzle library into Swig, and then you could create the signal processing graph of your instruments from within Smalltalk.
I think Damien had a question about how this relates to live programming systems like Sonic Pi or Overtone. I don't know if you've tracked some of those other projects and have any thoughts on that.
Well, I love Sonic Pi. I played with it for a while once when I was doing a trip around Australia with the developer going to conferences. Obviously, Smalltalk isn't a live coding event, but you could make an interface. I mean, you could. I guess what we saw this simple demo of the buttons to control different layers of synthesis is live programming. You could certainly have an event generator object that is playing and that you're sending messages to. So you could use this for, Siren could certainly be used to alter Siren objects that are in a scheduling thread while the thread is running. So there's no reason not to do live programming with it.
I don't know if that answers your question, Damien, but it sounds sensible.
I'm an old school composer, so I normally sketch things out and play with things play with them live, but then kind of refine the score. So I guess I'm the wrong, this beard, this isn't blonde. I don't know how it looks on the screen, but this is gray. So I'm not the generation.
It takes a certain confidence to stand up in front of an audience and like really both program and imagine what you're doing at the same time, I would imagine. So yeah, I agree with you.
Well, every university in America has some live laptop ensemble. And I guess it started with Princeton, and then Stanford had one, and we have one now in Santa Barbara where they give, 5 students looking at their laptops doing live performances. And it's just like any other live music that there are times where I've said that was amazing and could not have been pre-composed. And times where I said, well, I'll never get that 20 minutes back.
Stephen, are you part of the Top Lap live coding community?
No. As I just said, I'm still trying to figure out how to do it very slowly out of real time. So
I've got a question. Do you, I think from a software architecture kind of point of view, to have that kind of separation between the kind of the events and then the kind of sound processing, between Siren and Sizzle with the OSC kind of protocol between, seems to make, a good kind of logical sense. But do you think from a kind of compositional or kind of creation thing, there's sometimes something where you're kind of going against that nice software architectural or kind of technical architectural thing, where you're kind of messing with things in different layers at different times? Am I making sort of sense? In other words, you're starting to kind of mess with the DSP algorithm as part of a kind of compositional flow, and things aren't nicely separated. Things are more messy. Does that figure in, or do you find as a composer, you're just doing it kind of offline and it's not really a big deal?
Well, first of all, there is a continuum between composition and performance. In the old days, it was pretty clear that a composer would write out of real time, and then he would hand the score. He would create this document and give it to someone else. Now, maybe he was playing in the ensemble, but he wasn't always the full ensemble. When I was a student, it was the kind of the age of modular analog synthesizers. And there, of course, the composition and the sound design are so intermingled that it's not often clear whether you even want to differentiate. There's a lot of electronic music done on synthesizers, analog or digital, where it doesn't matter. The live performance isn't an issue, and the result is what it is. In terms of live coding, that's just another kind of interactive electronic music. I think the fact that you're programming isn't different than moving cables on an analog synthesizer and turning knobs. You can interact at a higher level because you can have compositional algorithms, what I call event generators, but it's still just live interaction with something that is both procedural and signal processing. But my way of working is just, I guess I just showed my hand. I build things frequently that start with just stochastic things saying, can I get from this sound to that sound to this sound in some organic way? And then I start building more and more constraints. Well, how about if it starts with the pentatonic scale where there are no dissonances? And then by the third time it comes around, it's playing a Boland-Pierce scale where there's only dissonances. And just, it's a famous thing of, well, people used to call it Markov, in terms of you would start with randomness and then build a bunch of filters to constrain the randomness. And eventually you end up with something that will always be played exactly the same every time because the filters outweigh the stochastic stuff that you started with. But again, Smalltalk being so malleable and having this idea of have something running and interact with it would be perfect for live coding, whether you're doing the synthesis in Smalltalk or the synthesis with the backend. I also want to say one other thing, Alan, which is I don't have the slides right in front of me, but when I came to Santa Barbara in the 90s, was kind of the beginning of people using networks of workstations to do supercomputer kind of things. I mean, there was a project at Berkeley right around the time I left in 95 called Network of Workstation, the NOW project. And one of the things we started doing, and I have a picture showing one computer running the compositional algorithms, and then a high-speed network, and then a host of, like a server farm, we would call it nowadays, where you say this server is just running the violins, and this server is just running the cello, and this server is just running, right? So for scalability, I think there's still reasons to have sound synthesis servers. Say I give my entire computer to composition, and then it sends out commands. That also allows us to say, well, the computer I'm composing on is an iPad or is, a mobile device. And then I've got a rack of something, or maybe I'm just talking a bunch of mobile devices, and then the sound synthesis server is just a normal laptop. But separating those, I still think there are reasons to do that.
Stephen, hey, have you done any work where you are actually accepting waveforms from other instruments outside of, in other words, you're not just generating music, but you're actually manipulating music from some other source?
The current version, no. In previous versions, both when I was working on it in Squeak, which would have been, when did Squeak come out? I guess late
96.
90s. Yeah, right, because it was right after I got to, it's a funny story. It was very shortly after I came down to Santa Barbara, and Dan Ingalls emailed me and said, hey, we're making this release, and could you very quickly, like today or tomorrow, could you download this and put it up on your FTP server? And I said, sure, yeah, okay. And then a couple of weeks later, I said, why did it have to be that day? He said, oh, Apple had just signed that they would let us release Apple Smalltalk as Squeak. And I wanted to be able to tell them that it was already on a university FTP server in case they changed their mind. That, nope, it's out. You can't ever take it back. It's out there on the interwebs. Something called .edu has it on an FTP site. But at that time, we did a fair amount of work with, importing things, doing signal processing. I guess Dan Ingalls wrote a Fourier transform in Squeak that had pretty good performance. When I was using Swig also with that package I mentioned called Loris, it was about importing sound, processing it, and exporting it again. I did a whole, a 15-minute long piece that all involved cross-synthesis of the voice of Gandhi with whale songs. And that was, so I have at times imported sounds, processed them in. So there is a whole model in Siren of sampled sound as being just the actual samples.
That's cool. Thanks. Yeah, I was just wondering about that because, you know, there, I know that there's this sort of, you know, bedroom industry, I guess, of people who make their own effects units for guitars or keyboards, and they program them in C++ usually, but, you know, maybe these sorts of things could be done in Smalltalk, just like oscilloscopes could be programmed in Smalltalk.
Well, Tektronix was one of the original porters of Smalltalk for that reason.
Right, exactly.
Well, to get back to my rant, I think taking something like Quiz and making it richer, you know, the bloat of VisualWorks and Squeak and Faro is, I think, a big hindrance to people learning it. And so as soon as I saw what Juan was doing, I said, oh, okay, I love it. You know, the fact that it's still morphic. My concern about morphic is partially idealistic, that just MVC is there for a reason, but also the performance is always going to be difficult if you've got that heavyweight objects in a rich hierarchy. And the wrapper framework, you know, David and I wrote that in the 80s when it was still a real issue. You didn't have a lot of heavyweight objects because the garbage collection was going to kill you, or just the memory footprint of big apps.
To add more names to your list of ones to visit, and we're hoping to get Tudor talking about GT next month. But when you showed your little notebook with ways of navigating through the music, it did seem like that would be a very nice fit for GT in the way that they want to document software and talk about the visualization of languages and things. When you popped that up, I thought, oh, I bet that would look quite neat in GT. And I believe GT's, you know, roadmap, I think they might even have done it, is to remove morphic. I think Faro has tried to remove it as well. But you know, I mean, all the different languages have got their different strengths and weaknesses, and you know, we're fairly agnostic in this forum. We kind of like all of them, and we like to play with all of them. So
well, that's why I thought I'd pick a fight and insult somebody who's right here on the screen.
Well, they all have minimalism efforts as well. You could maintain your own minimal system with your own UI framework in it. I don't know if that would be too much of a tangent for your work, though.
See, making music is already a tangent from my work is the problem. If I was still at the university, I'd feel different, but lately I've been doing a lot of intellectual property research, and my job is supposed to be putting out actual film scores and making music. So all the coding is, as I said, no, I took a fair amount of time this spring and I loved it. It was fun to play with Faro. I was very impressed by a lot of the work that was in there. And Squeak is still pushing forward. But none of the three that I tried, you know, were, yeah, at the end I just, okay, I'll just stick in VisualWorks for now. The
Seems like there's this tension between,
because it's expensive. You're not, you know, and they don't keep up. The free version is always a ways behind. I don't know if they even have the new release on the public use license yet.
seems like there's this tension between you want to use something that's widely used and you want to use something that doesn't have stuff in it that you don't like. Seems like you have to pick one.
Well, as I mentioned, I really did have several conversations trying to convince David Leibs to say, look, we could do it in 2 weeks, port MVC and the wrapper framework out of our heads, not copy any code, but just everything from BitBlit up, including fonts and the whole window framework. And the way we did it in wrapper, which we never called wrapper at the time, we called it Navigator early on. But that framework, you know, there's a reason it's still in VisualWorks. It actually works, and it scales well, and it's been used for thousands of applications. And these things it's funny that, you know, it has about half a dozen of the most common design patterns are just there as names, like wrappers and dependency. Well, I guess we call observer pattern dependency, but it's kind of the simplest and the most compact, scalable The tools also, I've used just about every GUI construction tool, and I still like the VisualWorks. Just you lay it out, it brings up the, the fact that you can do absolute and relative constraints the way they solved it, so you can have windows that actually scale properly. Every time I have to use either the Apple tools or Qt, I dread having to do GUI design for other languages.
Yeah, it's a slightly different perspective, Stephen, on MVC versus Morphic. As you might remember, I have had a fairly long association with VisualWorks and managing the engineering and so on.
Well, now I know which Tim that is. Okay. I thought you were playing hard to get by not having a last name.
Oh, I'm sorry. I'm just so used to, it's like Cher. I don't need a last name. I'm too important. The nice thing about Morphic, and there's a lot of things I don't like about it, but the really nice thing that it brought in was avoiding the change update storm that so often destroyed MVC-based stuff. The idea of a change basically saying, okay, nil out this thing, and then the next time you display, work out what it is. That was such an interestingly powerful way of avoiding that particular problem that it's quite nice. Now, yeah, there's an awful lot of stuff in Morphic that's an appalling mess, but it does have that really quite big virtue. And yeah, the non-separation of the view controller stuff just still 25 years later makes me throw up a little bit in my mouth. But
that is the advantage of Morphic. That is exactly as it should be. It's a design choice, and it makes certain things way easier. It's really nice to program in if you don't have 100,000 objects that you need to show.
Well, or if you don't want to have multiple ways of interacting.
Yeah.
So it's fine as long as you don't ever want to say, I had something I could do graphically that I now want to talk to over a socket, or have a physical knob controller for. To get back to what Tim was saying, we did when I was still working at Park Place, and since then there have been a number of systems that fixed a lot of the change update issues by either using more intelligently the arguments to a changed message. Normally you just pass the symbol along, you don't do a lot of filtering on the symbol. But I think, what was the first Smalltalk? Did Smalltalk V have this idea of dictionary-based updates? Somebody did very early on, did filtering of updates to say, if I'm the car dashboard and you tell me the gas changed, I don't need to redisplay the speedometer. So you're just having dictionaries and filtering these update messages. And then of course, caching of views, you can get a lot higher performance in a complex user interface if A, the view hierarchy does filtering of updates, and B, the views themselves have an easy way of caching and saying, do something like a damage management or something on a per widget basis.
Yeah, I'm pretty sure that Morphic does that part okay, to be honest. It's interesting. I have spent a long time over the last 25 years working on very low powered machines because of my quixotic attachment to the ARM, which meant back in the old days, the original single core ARMs running at 7, 8, 12 megahertz with 4 megabytes of memory and so on. And it's been quite interesting over the years trying to convince people to, you should run on a really slow machine to see how your nice new widget in whatever framework runs when it's really slow. But now we're at the stage with the Raspberry Pis where, $50 will get you a machine that will run 1 billion bytecodes a second per core.
Right.
So a lot of those worries actually start going out the window. Unless by chance you're trying to work on making an ESP8266 run Smalltalk, which That may be quixotic even for me.
Well, I should say, by the way, remembering your accent, congratulations to all the Brits here that Apple just announced that they're ditching Intel and that the new Apple world will be running entirely on ARM-based machines.
Since 1985, I've been telling people that an Intel x86 is a waste of perfectly good sand.
Well, you know, it just takes Apple time because they only screw all of their developers and customers every 11 years. Every 11 years, they come to a new processor, and it's exactly on time for them to make all of their hard. I guess they should have come out with another plug because they haven't ditched USB-C yet. I figured, you know, they went from desktop bus to USB to FireWire to Thunderbolt. Now there's USB-C. It's kind of time for them to screw all their development partners by saying, no, the new plug for you.
I think they should only sell power adapters that have UK-style mains plugs and make America convert to a sensible electrical system with a proper manly voltage.
Okay, time for me to hang up now.
Although sensible UK plugs is an opinion that's only held in the UK. You know,
which is the only opinion that matters properly, of course.
It's getting very small, the UK.
You know,
well, I have an electric car.
I feel like an island.
240 volts in my house. Does that count?
As a side note, since we're talking about the UK, if you're here in London and you Google for Swig, what you get is a one delivery company, as opposed to the actual framework.
It stands for Software Interface Generator.
Yeah, but it's the second link. The first one is swig.co.uk. Sorry.
As in take a swig, yes, of course.
Yes.
Well, it's afternoon now, so I could start my day drinking. I'll finish this tea.
It's over the yard arm in London, so you're okay. Actually, the sun's probably back down below the yard arm in London by now.
So, Stefan, I see you reached out to Ronnie about Swig and Faro.
Yes.
Yeah.
And he answered. So.
Okay. So
and he is very active at Faro at the moment. I guess he is in Lille.
Yeah, I think so. I think he's working with Steph's team. So.
Yeah.
Yeah.
Well, I guess I can butt in here and say. Another shameless plug. If you go to either my homepage or the FastLab pages or the GitHub pages, there are tons of papers about older projects in Smalltalk, several of which at least don't work anymore because of things like Swig. But I know there are screenshots in a couple papers from the 90s about using Loris with VisualWorks. And that's where you were passing big things back and forth, sample buffers, and constructing signal processing graphs in C++ that were modeled by object graphs within Smalltalk, all using Swig. And Loris is it was this very brilliant fellow's PhD thesis at University of Illinois. So it's basically a refinement of a Fourier transform spectrum representation that uses what are called bandwidth enhanced partials. So you model noise as being sinusoidal partials that have a non-zero bandwidth. So noise is always associated with the spectral components. And it means you have this unified representation that can handle things like speech extremely well, because speech has, often very prominent musical or pitched parts and very prominent noise parts.
Can you repeat the name for the thing you are describing? Sounds interesting. Can you, Stefan, please repeat the name?
Oh, Loris, Loris, which is the name of another, in Illinois, they call all their products like Kima and Platypus. They call them after obscure animal. I think Loris is like do you remember, Craig? It's like a sloth or something, or a lemur. I think a loris is some primate.
I don't remember that one.
Looks vaguely similar to a small lemur. Yes, slow loris is one of the ones. They have. They actually look a bit like those creatures from that comedy horror movie that you mustn't feed after midnight. Big ears, big eyes, furry, cute.
Gremlins.
Pet them.
Well, there was a bunch of work in the 90s on unified spectral representations. And Loris was a processing framework that was extremely powerful, and I use it for this piece with and the piece is on my Vimeo too, if you want to look at it, the piece that involved the voice of Mahatma Gandhi and whale songs.
Okay, I will try to find something about this. Thank you.
And also, as I mentioned, there are screen share demos of both Siren and Sizzle. Those are all linked to from the GitHub pages. And I apologize for the color scheme on the 2007 Smalltalk version. I think that's one where I had purple screens with yellow font, something. I don't know why I did that.
It could be worse. It could be like the 6 wiki pages, SIXX.
I'm not allowed to go anything with more than 2 X's in a row. No, that's.
No, if you Google SIXX, put sunglasses on before you actually click on the link, because color choices.
I'll type from across the room. Yeah.
Yeah. Good code, but holy cow.
I have a question. We referred earlier to MVC as something worthwhile that, and we were talking about Quiz as well. I suspect that we're talking about something other than literally the MVC of 20 or 30 odd years ago. Could you say something about what it would mean to have MVC available, for example, in Quiz?
Well, I am kind of talking about the MVC of 30 years ago, 40 years ago, maybe. It means just, for me, it's separating views and controllers. And as we did in Wrapper, which is, I guess, 30 years ago, that was late 80s. I don't think you have to merge everything. I think windows are allowed to be separate from the display list hierarchy, right? In original MVC, you had this standard system view, and they didn't really have a display list framework per se. In other words, window composition wasn't done the same way that a drawing was done. I think that's a good thing. And in Wrapper, the system in VisualWorks today, it's based on a very simple MVC. It could theoretically be ported all the way down to BitBlit. So I still like, especially since, as Tim was saying, a Raspberry Pi nowadays has an awful lot of skill. I like the idea of being able to run your Windows system all the way down to BitBlit if you have a machine that has no Windows system. I don't know why there aren't. I would love to get rid of the operating system and just run any Smalltalk variant as the main operating system. But the 2 things that I think are most important about the Wrapper framework is separating out views and controllers, because you've seen I have all these graphic things and separate from the interaction things, and then having the composition of having more different flavors of composable things. Like that, I guess that's why people started calling the framework Wrapper, because when you start debugging an app, you've got 6 layers. You've got bounded wrapper and then scrolling wrapper. Within that, I'm sure it's annoying, but I think it's the easiest and most scalable way to build complex GUIs. So.
Well, I think you should bring it back. I don't see how you're going to escape the Wrapper framework development business for doing what you want to do.
Well, unfortunately, I left the university 10 years ago, so I can't push people around and offer grad students degrees for doing work like this.
I mean, for your own pieces, your own work, your own artistic work.
Well, I did contemplate it, and I did talk to David Liebs, but he just had a grandkid, so he wasn't going to be taking on programming projects. He was doing granddad duty, and that was the one thing I couldn't push back against. His wife would literally kill me. So.
Sure, but you could take all that over yourself.
Not going to happen, Craig.
Too bad.
Remember, I still have a job, which is actually doing intellectual property consulting, And my main hobby is still writing music. And
but I guess performance might not be so bad. You can just run it on top of Morphic. There's nothing that says you cannot have controllers. And just use the morphs as views. There's nothing wrong with them. And overhead with current machines.
yeah, but if I'm going to start at the level of having to reinvent standard system view and standard system controller, I might as well do it to talk out the back either to PostScript or to BitBlit rather than running it on top of Morphic. Or I guess OpenGL, it would be the more modern way, just have the lower classes all just produce OpenGL.
And that's that, I guess, on Mac.
I don't know.
Yeah, yes, OpenGL is dead on Mac, but
I kind of agree with Stefan here. I don't think that Morphic forces you to integrate your model and your graphic user interface together. For me, a good style in programming with Morphic is to build models that are completely independent of the UI, and then have Morphic UI talk to it. And having an MVC or any other way of interaction should be possible. You mentioned controlling stuff from a socket, for example, or things like that. If the boundary between model and view is well defined, that can perfectly be done. I mean, Morphic integrates the view and the controller, but it doesn't integrate the model. There's no need to do that. You shouldn't do that, actually. I think it's better not to do that.
Well, it's like there are many other user interface libraries that merge view and controller, and they call it the widget or the interactor. I'm just saying, for purposes of reusability, it's nice to separate views and controllers. And of course, I could have some morphs that only do interaction and some morphs that only do display, and work around the fact that Morphic doesn't separate. But I thought it worked well in original Smalltalk, and I personally have in a lot of my apps, separate composition of view and controller components. Of course, I could call them all morphs, and they could all inherit 10 unused instance variables from the superclasses, and
or make them not inherit from morph, right? If you don't need.
I guess this was the problem of Morphic itself. I mean, it was bloated, and it is seen as bloated because it had lots of stuff just in that morph base class. And if you, for instance, if you now look at Faro, where you have traits, and you could have even stateful traits, and then you could compose, because you could have, let's say, things are positioned or named or initialized or described. So you could have such traits and then compose the classes out of them.
It actually just is not a problem.
Okay.
And it is in block, it's even worse. And it is just not a problem. It performs well enough.
Yeah, I'm pretty sure one of the reasons
it's better for reusability if you have that in terms of mix-ins instead of just having a basic single bloated class, superclass.
Yeah, I'm pretty sure one of the reasons that base morph ended up seeming very bloated was a side effect of Alan's group doing eToys and so on, where the idea was that you didn't have much in the way of subclasses of morph. You attached one or more costumes to your morph that represented the visual presentation of it, and you added scripts to them for their behavior and so on. So I think it was back then there was an idea of push all the important, as they saw it, state and capability up as high as possible so that everything else If you needed to make a subclass, it didn't really need much. It's a different way of doing it, and it, it has its pluses and minuses. Mostly it needs decent documentation. And one of the things that you will never find in any Smalltalk or other code system I have ever come across is anybody putting effort into documenting what they've done properly. But that's a rant for another day or decade or century, because it will take about that long to go through.
I'm sorry to go off topic, but
I've got time.
but a quiz exists as a reaction to that, right?
Good for you.
I think that Morphic got bloated because of itoys, and I said we need to remove itoys in order to clean Morphic. And after some time, when it was evident that this would not be adopted as the next Squeak version, that was what I wanted when I started it, I said, okay, then I'll name it something else, and I named it Quiz. But it's exactly that, a reaction to the excess of bloat in Squeak Morphic because of itoys.
Yeah, it's still there. It's, yeah, it shouldn't be.
But
And do you think
have Quiz, right? if that concerns you, please explore Quiz.
Yeah.
It was good for us.
And Juan, how do you feel about the level of documentation for Quiz?
Well, we have been writing quite a bit. If you take a look at our GitHub repo, there is quite a bit of documentation, and we also have been at the same time reducing by at least an order of magnitude the amount of classes and code in the system and writing better comments for them. So I think the system is easier to understand because it's smaller, but also because it's better documented and more intuitive than Squeak. That is a long-term objective for the project.
It is much easier to understand than both the version in Squeak and the version in Faro.
Yeah.
I looked at it at the time when learning Morphic. I learned Morphic 5 years ago or so. And that was quite difficult. I had to look back into mailing lists from 15 years, 20 years ago to find things. But code in Quiz is clean.
Is there a reason that Quiz is actually Squeak pronounced backwards?
Well, you know that Squeak is the voice of a small mouse, right? In South America, we have a countryside mouse-like animal that in Spanish is called quiz.